Hi there, this is Penelope. This is a short video for DE4102 and it's just a brief introduction to using Excel and some of the trig functions that you've learned and looking at how to draw graphs in Excel of the sine curves that we were looking at before. There are lots of trig ratios that we can use in the spreadsheets and they are exactly the same as we use in non-Excel. So we would use sine and put our angle in there. We'd use cos. We can use tan. We can use secant, which we abbreviate to SEC. Then cosecant. And then cotangent. And remember, we need the arrows, we need the equal sign to tell Excel that we're putting in a formula, not just some entry. But, and this is a really big but, these spreadsheets only work if the angle is in radians. So, to find the trig ratio for some angle that we've got in degrees, we first must convert it into radians. And either you can convert to radians arithmetically, or you can use another command to do that. For example, to find sine 30, you could use the command equals sine, and then you could convert 30 degrees into radians. So you'd multiply it by pi, and the multiply in Excel is an asterisk, and then we'd use pi and just brackets, and we'd divide that by 180, and we could do it that way, but it would be easier if we actually used the radian command. So we might say sine, and then we'd use another command. And what that does is it converts 30 degrees into radians first, and then it finds the sine of that. If we've got B3, if we've got something in B3 and it contains, so B3 is in angles, in degrees, then we're going to use equals cos, and we may as well use the Excel command to turn it into radians itself, and whatever is in B3. If we want to find the tan of 3 pi over 4, we would use the equals to tell Excel that we want a formula. Tan, and then 3 asterisk pi, to make sure it's the multiplication. Then we just have open brackets, close brackets, divide by 4 and close those brackets there. I think I've got an extra bracket in there. We're going to do some exercises now, and I've recorded these exercises in the PDF of this video. So now we're going to go over to Excel and we're going to find the answers to these questions in Excel. If we've got just plain 4, as we have in question 1, that means it must be in radians, because otherwise it would have a degree symbol. So it's already in radians, so the command is going to be equals sine 4. And we'll do that, equals sine 4. And we get negative 0.756802. We will format them at the end. The next one, it's telling us pretty clearly that it's all the angle measure is in degrees. We need to change it to radians first, so we'll just use the command that we've got inside Excel. So we need to turn it into radians first. And then the Excel spreadsheet knows that we've taken 4 degrees, we've converted it into radians, and then we're finding the sine of it. So equals sine, open your brackets once, then radians, open the bracket again. We need to do it of 4, and then we'll close our brackets twice. The next one, we're finding the inverse sine. And when we looked at these, I did mention that these could be called arc sine. So it's the arc sine, the command is a sine. So we're going to want the answer, we need the answer in degrees, because remember, that's the kind of answer you will get. You're not inputting degrees, but your answer is in degrees. So you need to tell the computer, first up you're using a formula, then you want your answer in degrees, and you're going to use the arc sine function. And because it's the angle that we're using is pi by 6, it's already in radians. So we don't need to tell the computer to put it into radians, because it is in radians, because it's pi over 6, right? We know that's in radians. But we want the computer to convert the answer into degrees rather than giving us an answer in radians. So we're going to do that, equals degrees, there it is there. We will, the bracket is already open, so now we're going to use a sine, it should bring it up. And then pi. And we just need to close the brackets there and divide that by 6, and then put in enough brackets, which will be 2. Yes, so 31 degrees is the inverse sine of pi by 6 in degrees. Question 4. The angle is given to us in degrees, so we need to ask the computer to change it first. So we're going to say equals cosine, and then we'll use the radians command on 120, and I need to have 2 closing brackets. Equals cosine, use the radians. You can type them in, or you can double click on it and get it in. 120, close brackets twice, negative 0.5, which you should have known. The next one, tan 5 degrees. We need to convert the 5 degrees into radians. So we'd have to use both the tan function and the radians function, and we're doing it on 5. So we're converting it to radians first, and then we're finding the tangent. So call up the tangent function, open your brackets, you call up the radians function, and you want to apply that to 5 degrees, like that. I think the question for that is actually tan 5. So just to keep our questions consistent with what you've got in your notes, we'll use tan 5. Now, if it doesn't have a little circle, it means it's in radians, so we don't need to bother about converting it, and we can just go equals tan 5. The next one is back in degrees, so we need to convert it first. We're using the sine function, then we need the radians function to convert it, and it was 140. So we converted it into radians first, then we find the sine of it. Now, inverse cos, it's not got a little degree symbol, so we can assume quite safely that it's in radians, so we don't need to convert it into radians. So we're going to use the inverse cos, which is arc cos. And we can just go 1 over 1,000 to get our answer, equals arc cos, should be there. Oops. And then 1 over 1,000, close our brackets, should be good. And the last one, it's asking you to find the angle given that the tan of the angle is 2 cubed. So that means we have to use inverse tan or arctan. And the answer is to be in radians, which is fine because that's how Excel thinks, so we don't need to convert it. And we'd go 2 little hat 3 equals a tan, should bring it up, 2 to the power of 3, and we're done. We can now check the solutions and the commands, and we got them all right. Fortunately, we got them all right. Okay, now we're going to look at drawing sinusoidal waveforms. Again, I'm going to go over to Excel so that we can draw these ones, particularly that bottom one where we've got y equals 3 sine 2x plus 30. The function that we're asked to draw is y equals 3 sine 2x plus 30 degrees. So clearly it's in degrees, so we need to convert the degrees into radians so that Excel will understand. You'll notice I've only put the x values down to 180. Look at the period of this. Remember, the formula is going to be 360, because we're working in degrees, divided by omega, and omega in this case is 2. So we only need to have the x values up to and including 180 degrees. Now for our y values, equals to get us into the realm of formulas, sine, because that's what we've got. Now the numbers are in degrees, so first up we need to calculate to radians, and then it's going to be 2 times whatever's the x value plus 30, and then close the brackets enough times to match. No, that's not quite right. I forgot to put a 3 out the front. So it needs to be 3 times that. See, my formula just says sine, but it should say 3 times that. Now it should be right. 1.5, yes. So then fill that down. You'll see some of the numbers look a bit weird. The one for 75, for example, that's really 0. So that's what you would expect it to be anyway. Okay, so we're going to now highlight all of that. We're going to go to Insert Chart, and we may as well have the points on the chart like that. We need to make it look a little bit nicer maybe. We need to, let's look at the axes, or the axes themselves to start off with, because we need to probably put a bit more on the axes than we've got. The horizontal one really needs to be not in 50 degrees, but in 15 degrees to match what we've got in our table. So that works for that. Now we also need to probably put axis titles in. So we can put the titles in. Yep. And the y, okay, we could edit that, equals 3 sine 2x plus 30 degrees. and we need to maybe put our axis title as X. And I could shift that probably up to here. And I could either rotate this one or I could leave it as it is and just call it Y. And there we have it. We would have expected the graph to look like that because it's a shift and it's a stretch. The amplitude is now 3. So it is what it is expected to be. That's how you draw a graph using Excel.